JavaScript operators are special symbols that help us perform calculations, compare values, combine conditions, and manipulate data. They are the building blocks of programming logic. Arithmetic operators perform mathematical calculations. The addition operator adds two numbers. For example, 5 plus 3 results in 8. The subtraction operator subtracts the right operand from the left operand. For example, 10 minus 4 results in 6. The multiplication operator multiplies two numbers. For example, 3 multiplied by 4 gives 12. The division operator divides the left operand by the right operand. For example, 15 divided by 3 gives 5. The modulus operator returns the remainder of a division. For example, 17 modulus 5 gives a remainder of 2. The exponentiation operator raises the left operand to the power of the right operand. For example, 2 to the power of 3 gives 8. Increment and decrement operators increase or decrease the value of a variable. Prefix operators like plus plus x or minus minus x modify the variable first and then use its value. For example, if x equals 5, plus plus x first increments x to 6 and then returns the value 6. Similarly, with prefix decrement, if a equals 10 minus minus a first decrements a to 9, and then returns the value 9. Postfix operators like x plus plus or x minus minus use the current value of the variable first and then modify it. For example, if x equals 5, x plus plus first returns 5, and then increments x to 6. Similarly, with postfix decrement, if a equals 10, a minus minus first returns 10, and then decrements a to 9. Remember that prefix operators modify before using and postfix operators modify after using the value. Assignment operators assign values to variables. The basic assignment operator assigns the value on the right to the variable on the left. For example, let x equal 10. The addition assignment operator adds the right operand to the variable and assigns the result. For example, if x equals 5, x plus equals 3 is equivalent to x equals x plus 3, making x equal to 8. The subtraction assignment operator subtracts the right operand from the variable and assigns the result. For example, if x equals 10, x minus equals 4 is equivalent to x equals x minus 4, making x equal to 6. The multiplication assignment operator multiplies the variable by the right operand and assigns the result. For example, if x equals 3, x times equals 4 is equivalent to x equals x times 4, making x equal to 12. The division assignment operator divides the variable by the right operand and assigns the result. For example, if x equals 15, x divided equals 3 is equivalent to x equals x divided by 3, making x equal to 5. The modulus assignment operator divides and assigns the remainder to the variable. For example, if x equals 17, x modulus equals 5 is equivalent to x equals x modulus 5, making x equal to 2. Comparison operators compare values and return a Boolean result. Regular comparison operators perform type conversion before comparing. The double equals operator checks for equality after type conversion. For example, 5 double equals the string 5 is true, and 5 double equals 5 is also true. The not equals operator checks for inequality after type conversion. For example, 5 not equals the string 6 is true, and 5 not equals the string 5 is false. The greater than operator checks if the left operand is greater than the right operand. For example, 7 is greater than 5 is true, and the string 7 is greater than 5 is also true. The less than operator checks if the left operand is less than the right operand. For example, 5 is less than 7 is true, and the string 5 is less than 7 is also true. Strict comparison operators do not perform type conversion. The triple equals operator checks for equality without type conversion. For example, 5 triple equals the string 5 is false but 5 triple equals 5 is true. The not triple equals operator checks for inequality without type conversion. For example, 5 not triple equals the string 5 is true, but 5 not triple equals 5 is false. The greater than or equals operator checks if the left operand is greater than or equal to the right operand. For example, 7 is greater than or equals to 7 is true, and 8 is greater than or equal to 7 is also true. The less than or equals operator checks if the left operand is less than or equal to the right operand. For example, 5 is less than or equals to 5 is true, and 5 is less than or equals to 7 is also true. Strict comparison operators are recommended for more predictable code. Logical operators combine or modify Boolean expressions. The AND operator returns true only if both operands are true. The OR operator returns true if at least one of the operands is true. The NOT operator returns the opposite Boolean value. For the AND operator, if both A and B are true, the result is true. If either A or B or both are false, then the result is false. For the OR operator, if either A or B or both are true, the result is true. If both A and B are false, then the result is false. For the NOT operator, if A is true, then not A is false. If A is false, then not A is true. For example, an authentication check allows access to the dashboard only if the user is logged in and has permission, otherwise, it redirects to login. In form validation, an error is shown if either username or password field is empty, otherwise, the form is processed. The conditional or ternary operator is a shorthand for simple if-else statements. The syntax involves a condition, followed by a question mark, a value if the condition is true, a colon, and a value if the condition is false. If the condition is true, the first value is returned. Otherwise, the second value is returned. Consider traditional if-else statement that returns the string adult if the age is greater than or equal to 18 and minor otherwise. The same thing can be achieved by using a ternary operator, which returns the string adult if age is greater than or equal to 18 and the string minor otherwise. Ternary operators are best for simple conditional assignments. A practical example is dynamic class assignment, which assigns btn active if a variable is active is true or btn inactive otherwise. Another example is conditional rendering, which displays welcome admin if the user role is admin and welcome guest otherwise. Ternary operator can be used to provide default values. For example, username will be equal to the value of input if it exists or anonymous otherwise. Avoid nesting ternary operators as it reduces code readability. Bitwise operators operate on the individual bits of numbers. The AND operator returns 1 for each position where both bits are 1. For example, 10 and 12 is 8. 10 is 1010 in binary, and 12 is 1100 in binary. The AND operation gives 1000, which is 8 in decimal. This is used for checking if a specific bit is set. The OR operator returns 1 if at least one of the bits is 1. For example, 10 or 12 is 14. 10 is 1010 in binary, and 12 is 1100 in binary. The OR operation gives 1110, which is 14 in decimal. This is used for setting specific bits to 1. The XOR operator returns 1 only if the bits are different. For example, 10 XOR 12 is 6. 10 is 1010 in binary, and 12 is 1100 in binary. The XOR operation gives 0110, which is 6 in decimal. This is used for toggling specific bits. The right shift operator shifts bits to the right, filling with sign bit. For example, 10 right shift 1 is 5. 10 is 1010 in binary, right shift by 1 gives 0101, which is 5 in decimal. This is used for quick division by powers of 2. The left shift operator shifts bits to the left, filling with zeros. For example, 10 left shift 1 is 20. 10 is 1010 in binary. Left shift by 1 gives 10100, which is 20 in decimal. This is used for quick multiplication by powers of 2. The NOT operator inverts all bits. For example, NOT 10 is minus 11. 10 is 1010 in binary. NOT operation gives 0101, which is negative 11 in decimal, because of 2's complement representation of negative numbers. This is used for bit masking operations. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.